Okay, we are going to be looking in this lesson at various kinds of polynomial rational expressions. So what is a polynomial rational expression? In the simplest form, it's a polynomial divided by another polynomial. So this would be something like this: 3a squared minus 7a plus 2 divided by a squared plus 2a minus 8. That would be an example of a rational polynomial expression, okay? So, how do we simplify those? Well, first of all, let's look at numbers, fractional numbers, such as 16 over 36. We can simplify this the way you've always simplified it, simply by dividing by 2 or some other common factor. If you don't see it right away, they're both even, so 2 is a good way to go. That gives me 8 divided by 18, and now that can be simplified again. So divide by 2 and divide by 2, and this will give me 4 over 9. Now 4 over 9 cannot be simplified anymore. This is the way we usually simplify fractions, but there is another way to simplify fractions, and that is you take your fraction and you can write down factors. So for example, 16 is 4 times 4, and 36 is 4 times 9. Notice 4 divided by 4 produces 1, and so you're left with 1 times 4 over 9. And there is your simplified fraction. Now, when we deal with a polynomial rational expression, we are going to use this method right here, where we factor the expression. Remember, I said the next 2 lessons are going to be using your factoring over and over and over again. So we're going to factor the expressions, look for common factors between the numerator and the denominator, and cancel them out because something divided by itself is equal to 1, and then that leaves us with whatever the answer is. So let's look at this one. The same principle that we just did. Let's start with another one that's simpler than that one that I put up there. Okay, so how about this one? 3a squared plus 9a over a squared minus 9. Okay, notice the first one has common factors of 3 and an a. So we're going to pull out that common factor of 3a. 3a times a will give you 3a squared, and 3a times 3 will give you 9a. So that one is factored. Our second one here, a squared minus 9, this one happens to be a difference of squares. So remember, in your difference of squares, you have 2 binomials, a times a, and then the square root of 9 is 3, and so 3 times 3 is 9. You have a plus and a minus. Now notice, we have a common factor, a plus 3. A plus 3 divided by itself is 1, and we end up with 3a in the numerator over a minus 3 in the denominator. And you're probably wondering, why can we not cross out the a and the 3? Well, the difference is they have to be factors. That means it has to be multiplication between the things that you're eliminating. 3 times a, but this is a minus 3. This is addition and subtraction, not multiplication. Therefore, this cannot be simplified anymore, okay? So, let's look at another one. 3a squared minus 7 times a plus 2 over a squared plus 2a minus 8. Okay? So, let's factor these. The numerator is going to be a 3a times an a. And 2 can only factor into 2 times 1. So, we have the same sign because it's plus 2. Minus says my middle sign is minus for both of them. And 2, we're going to have to get to 7. So 3 times 2 is 6. And then 1 times a is a. So it's a negative 1a minus 6a, which will give you a negative 7a. The denominator has a times a. This one is a negative before your 8, so you're going to have a plus and a minus. 8 only has 1 times 8, which won't give you a 2. So you're going to have to use 2 times 4. The 4 is going to have to be positive because my 2a is positive. So this will have to be 4, and this one will have to be 2. Now notice, I have an a minus 2 up here and an a minus 2 here. So those two equal 1, and you are left with 3a minus 1 over a plus 4. As you can see, they're easy to simplify when you factor. So you have to factor before you simplify. Let's look at another one. Okay. I've got AM minus BM plus AN minus BN. And this is over top of AM plus BM, and then plus AN plus BN. Okay? So what are we going to do? This is 4 terms and 4 terms. So let's group our first 2 because it has a common factor of m. Group our last 2 because it has a common factor of n. And then this one's going to be the same thing. Common factor of m, common factor of n. So now let's factor these out. Pull out my m, and you have a minus b. Pull out the n plus n, and you have a minus b. Let's keep going on that one and finish that one up. Notice your a minus b is your common binomial factor, a minus b, times m plus n. That one's finished. Now let's look at this one. Again, m is your common factor, and this is a plus b, plus n is your common factor, and a plus b. Okay, you see those common factors? And now notice, a plus b is the common factor, common binomial factor. So we'll pull that one out, a plus b, and you're left with m plus n for your second binomial factor. M plus n is the same on the top in the numerator and the denominator. So this is equal to a minus b over a plus b. And those are not factors anymore. They're additions and subtractions. So therefore, it cannot be simplified anymore. So let's look at something else that will show up when you're doing this. If you have an a minus 3 over a 3 minus a, these are except for a negative 1. So to show you that, we're going to factor a negative 1 out of the denominator. Okay? So this will be negative 1 times negative 1 times negative 3, negative 1 times plus a gives us that. Change our order, so you have a minus 3 over negative 1 times a minus 3. Now you can see your common factor, and you have a 1 over a negative 1, which is equal to a negative 1. Therefore, whenever you see two factors that look almost the same, but they have a minus between the two terms, and they're just flip-flopped from each other like this, a minus 3, 3 minus a, they are equal to negative 1. So that gives you that information, which you're going to need later. So let's now look at multiplication of rational polynomial expressions. Okay? So when we're multiplying, that means we're going to have two or more. So let's look at these. And what we're going to do is let's look again at multiplication of simple fractions using the method that we're going to use, okay? So what are we going to do? Well, we're going to factor. The first one is going to be left with 3 times 1 over, let's go, 1 times 8 times, this one is going to be 3 times 8 over 3 times 3. Now, any one of the factors in the numerator can cancel any factor of the same in the denominator. 1 for 1, okay? So let's look at this. 8 cancels with 8. This 3 cancels with this 3, and this 3 cancels with this 3. That leaves us with 1 over 1, which is equal to 1. We're going to use this same method with multiplication of polynomial rational expressions. So let's look at one of these. 5 times p minus 5 over p times 3p squared over 10p minus 10. Okay, so let's start factoring. The numerator here is going to factor out your common factor of 5 and have p minus 1. The denominator has p and it cannot factor anymore, times my second one is 3 times p squared, which is 3 times p, and then 10p minus 10. This is going to be 10 times p minus 1. So you see we pulled out common factors twice and then factored what we could. Okay? P minus 1 cancels p minus 1. This p cancels one of those p's. Okay? Now, I notice that 5 will go into 10 because 10 is 2 times 5. So we're going to cross out those 5's. And that's going to leave me with 3 times p for my numerator. My denominator has only the number 2. So that is the finish of that one. You see, it's simplified way down. They don't always do that. Depends upon what they have. Okay, so now we're going to look at another one. Let's look at this one. K squared plus 2k minus 15 over k squared minus 4k plus 3 times k squared minus k over k squared plus k minus 20. Okay, so let's start factoring. As you can see, the first step for everything is to factor. So I'm going to factor this one. So come down here. We're going to have two binomials, k times k. 15 is 5 times 3, and they're going to be opposite signs, plus and minus. Since my 2 is positive, my 5 has to be positive, my 3 has to be negative, because that's 5k minus 3k, which gives you 2k. Okay, the denominator, again, we have k times k. Notice, this is the same sign because it's plus. This one is minus, so my sign is negative. 3 has only one possibility, 3 times 1. So that one's not so hard to do because there's only one possibility. Now let's look at the second expression. You have a common factor of k, so it's k times k minus 1. And the denominator has two binomials again, k times k. Negative 20 means that you're going to have a positive and a negative. And 20 that has a difference of 1 is 4 times 5, and 5 minus 4 is 1. So my plus is in front of my k in the middle, so my 5 has to be positive. My 4 is negative. 5k minus 4k gives you 1k. So they're all the way factored. Now let's look for those common factors. Here I have a k plus 5 and a k plus 5. On the denominator here I have a k minus 3, and this is a k minus 3. Now I have a k minus 1 on this denominator and a k minus 1 in the numerator. As you see, one has to be in one of the denominators and the other one has to be in one of the numerators. So is there anything more that's the same? No, there isn't. So what's left? I have a k in the numerator over k minus 4 in the denominator. And that's all there is to it. It's finished now. That is completely factored. It went from all this down to just that. So as you see, it happens pretty fast. Let's look at another one. I want you to be pretty comfortable when you start working on your assignment because you will have seen a number of different sorts of these. So let's try this one. P minus 4 times 3 over 5p minus 20. Well, this p minus 4 can be made into a fraction by putting it over 1. Notice, this one is already factored. 3 is already as well factored as it can be. There's only this one that needs to be factored. So rather than rewrite the whole thing, I'm going to just write it down below. 5 times p minus 4. Okay? Now notice, I have a p minus 4 in the numerator and a p minus 4 in the denominator. And that's gone. So in the numerator, you're left with 3. In the denominator, you have 1 times 5, which is 5. And this one is nice because it went all the way down to just simple numbers, which is kind of nice. Okay, let's look at another one. Just one more of these for multiplication. So we have x squared plus 2x over x plus 1 times x squared minus 1 over x cubed plus x squared. Okay? So, first thing we're going to do, top one here has a common factor of x. So this is x times x plus 2. The denominator is already factored. The numerator is a difference of squares. And remember, it's two binomials, x times x. Square root of 1 is 1 times 1, plus 1, and minus 1. So therefore you have your difference of squares. This one is going to have an x squared be pulled out, and we'll write it that way first, times x plus 1. Okay, so this x squared can be written as x times x. So now let's look at what we have between numerators and denominators. I have an x here. One of the x's is gone. X plus 1, x plus 1. And you know what? That's it. Nothing else the same. I could have chose this x plus 1 instead of this one. It really doesn't matter. So what is left on top? X plus 2 times x minus 1. And on the denominator, I have x plus 1. You can leave it in that format. That's all you have to do, and that one is finished. Oh, I forgot my x. X times, see, here's my x here, I forgot it. So be careful you don't lose something behind like I just did. So be careful about that. So x times x plus 1. Okay. We'll finish that one because it's got enough time, and we'll go